Go to our second part of these notes, we're going to remind ourselves that when you're multiplying polynomials, FOIL can only be used for binomial times binomial. It can only be used when you have a binomial times a binomial. So don't try to use it in any other situation. Only a binomial multiplied by another binomial will FOIL actually work. And really all FOIL is a distributive property, right? It's just doing distributive property, but giving us a method to do it. So let's FOIL this one first, okay? So what's the first thing I always suggest you do, though? Add the opposite. So our 2x minus 3, we will change to 2x plus a negative 3. And now we should be ready to FOIL it. Now you can FOIL it horizontally, or you can do it vertically. I give us plenty of room to do it vertically, so that's the way I'm going to do it. So go ahead and get this one FOILed out. Let's get our product. You get the same 4 products for your multiplications, which would be actually distributive property. Here's really what's going on with FOIL. Same thing we're doing right here. We are doing distributive property. We're really just taking this 2x times both of those pieces. There's the f and the o right there. And we're taking the negative 3 times both pieces. There's our I and our L step, isn't it? So we're really doing distributive property, but not with a monomial, rather a binomial. Okay, so what's our final answer for this one, cleaned up and everything? 6x squared minus x minus 12. Okay. Anybody need to challenge that or ask any questions about it? Okay, well the book showed a couple of different ways to actually do polynomial multiplication. The one I find that typically is useful for students and helps them be probably the most successful, especially once we get to more than just a binomial times a binomial. We might have a binomial times a trinomial. The rectangle method works well, and it works for actually anything. You can take a monomial times a monomial with rectangular multiplication. And so, how do we find the area of a rectangle? Length times width, side times side, right? So that's what's happening when we are actually doing, up here we had 4 multiplications going on. So let's do just like we did up there, change our subtraction to add the opposite. Well, because there's 4 terms, that means we need 4 smaller rectangles within a bigger rectangle. So here's my bigger rectangle right here. And then I've divided into 4 smaller ones. And we're going to take our binomials, and the terms of each of the binomials are going to become side lengths of these smaller rectangles. So we'll put 2x here and negative 3 here. And 3x up on top, and this one's going to be 4. And then what we do is we just take length times width for each of those smaller rectangles. So in this one, I don't want you to show any work in this one. I just want you to just show the setup in that particular one. And notice, it doesn't mean that you have to draw this many rectangles every time you do it. But in our notes, I want us to see what's really going on. Okay, so let's just transfer that 2x and that negative 3 and that 3x and that 4 over. And notice I made the rectangles a little bit bigger, stretched them out. Because now we're going to show what do we really do here? What's really happening? Well, we have to find the area of each of these smaller rectangles. So we take 2x times 3x for that first rectangle. It has those are its two side lengths. What would the multiplication be for the one right next door to it on the right? 2x times 4. Dropping down to the first rectangle in the bottom row, what would its dimensions be? Negative 3 times 3x. And the dimensions of this one would be negative 3 times 4. So again, you're not going to have to show this many rectangles, but in our notes, let's just have so we can see where it's all coming from. What step is this in FOIL? F. What step is that in FOIL? O. I. L. It's really the same thing, isn't it? So what does 2x times 3x become? What's the area of the first? 6x squared. What's the area of the next rectangle beside it? 8x. And the area of the rectangle below 6x squared, what's its area? Negative 9x. And the last one, negative 12. So we get the same products, don't we? We get the same 4 products as we got in FOIL. We still do the same thing. We add them together. We say these all need to be added together now. We just follow across each row. And we still end up with the same answer. 6x squared, subtract x, subtract 12. Just another method to show your work. It's doing the same thing, isn't it? Do you see the correlation between them? So in other words, what ends up happening is we kind of end up doing our FOIL, but just in a rectangle. There's our FOIL. Okay, the reason that the rectangular method is handy is because we don't have a method for taking a binomial times a trinomial, or a trinomial times a trinomial, and they can even get bigger than that. What do we do when we have those kind? Well, the thing is if you want to do it horizontally, like there's another way in the book they show just doing all the distributive property, it gets pretty long and you kind of run around a room on your line. The paper's only so wide. So when we use a rectangle, it actually kind of like gives us, it works out better. So let's first just do this, okay? Let's start with let's do this first. Let's change this to x plus a negative 5, and our other polynomial has 1 subtraction in it also, so let's change that. Now, I need to move that down a little bit. I don't want it to be right there. I'm going to come down here with it. And I'm going to put the first polynomial, I'm going to make it a 2 by 3, because it's a binomial times a trinomial. So I have my x and my minus and my negative 5. I'm going to have a negative 3x squared here. But I want to leave enough room to show the multiplication, because in our notes we're going to do this, okay? So let's make that rectangle about that big. Put the x here, and we'll make that rectangle about the same size, and our negative 4 here, and now we can finish up our rectangular array. Okay, let's show our multiplication here. X times negative 3x squared. We have x times x. And we have x times negative 4. And you set up the other 3 multiplications. What would the other 3 multiplications look like? then we'll just go below it and get ourselves the product rectangle. What will the products of all those be? So go ahead and do your multiplying in each of the rectangles and carry it down. Let me give you a little, you can actually, because addition allows us to add in any order we want. I'll give you a little hint though. If you go by columns rather than rows, once you're beyond binomials times binomials, if you go by columns, so in other words, I go down the first column, then I move over to the next column, and then I move over to the next column, typically what will happen is those like terms will already be lined up beside each other in your addition problem. So if you work down the columns across your rectangular array, when you're setting up your addition, they should line up nicely. So we have that negative 3x cubed that has no other term like it. How many x squareds do we have altogether? 16 of them. How many x's do we have altogether? Negative 9 of them. And the constant does not have anything to be combined with. Does this answer need cleaning up? Only one spot, right? So, negative 3x cubed plus 16x squared minus 9x plus 20. And you want to be careful, it takes only one little place. You don't put the exponent correctly or something, and it makes the whole answer wrong. Okay, you try the next one on your own. You need a rectangular array. I want you to practice this rectangular array. It doesn't mean you have to use it all the time, but I think you're going to find that it's a pretty efficient way to multiply. Use things in order better. You don't lose things along the way. Anybody got questions though that you need cleared up before you are trying to do this one on your own? And remember what I said, it doesn't really matter which one gets put on which side. You just get to make that decision. Before I move on, we challenge any part of this, if you do the same products as I did. This time going down the columns doesn't put them in the order I want them, but that's okay. Well, we get a good sized polynomial here, don't we? And I'll put my final answer and you can see if you agree with me. My final answer is up here in black. So just copy mine down and hope that I'm right. I might need to be challenged. Do I have anybody that has the same answer already? Oh, I do. Okay, let me check my completed notes, see if I got the same answer that I wrote it another time. I did. Okay. So I never do a problem like this and claim to be done until I go through and do a really quick check and make sure. Because it's so easy to make a simple mistake along the way. Carrying something down, exporting properly, or whatever. Anybody have concerns about multiplying? Or we have more than binomials and binomials?